Hello, hello. This is Joshua Soteris for IA Week 6, and we're going to be talking mainly about reinforcement learning. So, just some goals. Um, we're here to, I'm here to talk about, provide a comprehensive breakdown of how reinforcement learning, RL, elevates large language models beyond simple pattern imitation, how RL enhances reasoning, strategic decision making, and creative problem solving in AI. And just to highlight how modern LLMs leverage RL techniques like RLHF, reinforcement learning from human feedback. So, what is reinforcement learning? So, just the definition core concept reinforcement learning is a trial and error learning paradigm where an agent interacts with an environment and learns by receiving feedback, rewards, or penalties to refine its decisions. Unlike supervised learning, RL doesn't really rely on label datasets. Instead, it discovers optimal behaviors dynamically, and some core formulas as listed over here is like an agent. You can think of agent as an LLM, or the robot, the AI system. The environment, which are just basically text inputs, game simulations, or real-world tasks, actions, decisions made by the AI, and rewards and penalties. Feedback used to shape and better future responses. And I chose to put Mahar Aga here just because he is kind of like a concept of reinforcement learning and just the adaptation, just kind of, the topic we're talking about. So, how it works, right? An example is AlphaGo's self learning process in the game of Go. Instead of mimicking human play, it discovered new strategies through millions of self play iterations. LMs used reinforcement learning to refine responses over time with human feedback or external scoring machines, and we'll go more into this later. So, some so the limitations of RL is actually its sample inefficiency. Like just how we've been mentioning, it needs millions and millions of data and iterations to learn optimal strategies. Not only that, it's computationally expensive. It requires vast resources to simulate enough interactions for meaningful learning. And its practical application, it works best when combined with pre-trained models and fine-tuning processes. So the three stages of LLM training. The first is pre-training. We kind of already grasped this in the first like 3 or 4 weeks of class, and basically the objective is just to develop a general purpose language understanding computer to understand language, and to process this we need amounts of high quality diverse text data such as books, articles, code, basically the whole internet, right? And the outcome, we just want the model to understand the semantics of human language, right? And once this pre-training is achieved, it still lacks the structured reasoning for to actually understand or reason with language. So supervised training, right? Its objective, supervised fine-tuning, SFT, is basically just trying to shape the behavior, right? It makes the model act more like a helpful assistant. Human laborers, the process is where human laborers provide the ideal responses and basically teaching AI how it should respond. The outcome, well, the outcome it kind of more or less aligns with human expectations, but still follows the static patterns, right? And the reinforcement learning. So the objective is after those first two stages is just to optimize the model's responses by reinforcing useful patterns and discouraging incorrect ones. And the process for this within this stage, there's three of them. It's to the model generate responses, a reward model scores the responses, and the LLM adjusts its approach based on trial and error handling. And the outcome of this is the model develops self-improvement mechanisms beyond imitation. So what is the guess and check method, right? The guess and check method guesses a response based on its learned data, checks the quality of that response through feedback mechanisms, refine future responses by rewarding correct answers and discouraging incorrect ones. This mimics how people learn, right? And basically still kind of imperfected. That's why it's guess and check. That's why it's named guess and check. When a child, like an example is like when a child learns math, they try to answer, check if it's right, and adjust if it's wrong. Similarly, learning models test different solutions, and they receive feedback and improve through these signals, right? And the three early stages, right, is that the flaws or the early stages of responses, right, is that flaws, if I remember correctly, misunderstands user intent, sometimes misinterpreting context. Repetition, it relies on generic patterns and instead of like creating new responses, right? Inaccuracy, self-explanatory. It just generates false information. So, evaluating the solution, the quality of the response is assessed on based on multiple factors, right? First is coherency, right? Does it make sense? Does the response logically make sense? Are there in contradictions or inconsistencies in its response? An example is like the example here, good. Sharks are cartilaginous fish found in oceans worldwide, and a bad one with sharks are reptiles that live on land and lay eggs, which we know is not true, right? And the next one is faculty, right? AI models tend to quote unquote hallucinate information that sound correct but isn't, right? The next one is relevance. Does it answer the prompt, right? And creativity, it's basically generating like how useful, how creative a response it can have, right? So, for example, if a user prompts, "How can an AI improve healthcare?" a basic response would be, "AI can diagnose diseases," right? Which is common knowledge. But we want more of a detailed response, such as AI improving healthcare through predictive analytics, robotic assisted surgeries, and personalized medicine, which is more creative, right? And the reinforcement learning, right? With this, right, is that when good responses receive positive performance, it higher reward scores, right? What the user does is have a higher reward score, and poor responses is the opposite. We discourage it, making like uh, so we discourage it so it avoids making mistakes in the future. And the iterative process is that the LM continually refines the strategy, right? And it's kind of similar to like training a dog through positive reinforcement. We reward it with good treats if it does something good. So cognitive harmony and token, right? Basically, it's how LLMs and human process information differently, right? Humans, as we know, use intuition, prior experience, emotion to reason, and basically that, right? And we understand context. We just interpret situations using the world knowledge and make leaps in reasoning beyond strict logic, right? That's what makes us human, and we're adaptive and nonlinear thinking. We have nonlinear thinking. Human thought processes are not purely sequential. We can backtrack, revise our thinking, and recognize abstract patterns, while LLMs have to be trained to do this, right? LLMs, they process information purely through the probability based on token prediction, right? Um, they lack intuition, like us humans, and they have memory limitations, right? While recent advancements allow models to track longer contexts, they do not understand concepts as humans do. They simulate the understanding through token prediction, right? But reinforcement learning bridges this gap by encouraging optimal token sequences that lead to structured reasoning, right? So, like the lack of intuition, reinforcement learning tries to bridge this, right? Um, And why do these token sequences matter in reinforcement learning, right? Instead of choosing the next word, reinforcement learning optimizes these models considering the broader context of the entire conversations. An example is the currently GPT-4 maintaining logical consistency over multi-turn dialogues, right? By prioritizing meaningful sequences. So thinking models and chain of thought, right? Um, what is this? Reinforcement learning enables large language models, right, LLMs, to develop multi-step reasoning capabilities, much like how humans tackle complex problems by this concept, breaking them down into sequential thought processes, right? So why this matters, why this multi-step reasoning matters is basically LLMs generate responses by predicting the most probable next token, right? Without explicitly reasoning through the problem. So just choosing whatever is the best probability without even understanding context, right? Lacking the intuition. RL optimized LLMs to refine their approach by testing multiple token sequences, reinforcing the structure logical through the chains, right? Sounds so much similar to artificial neural networks, right? And then this basically leads into um, the concept of chain of thought, right? So chain of thought, or COT, prompting, right? Chain of thought prompting is a technique that encourages LLMs to reason through each step explicitly, leading to higher accuracy, deeper problem solving, and better logical flow. This forces the model to explicitly reason through each step, and it increases the accuracy and problem solving depth. So why does this work in reinforcement learning, right? LLMs struggle with complex reasoning when answering a single step, and COT guides this model to explain the reasoning step by step, increasing the clarity and accuracy, which reinforces the habit of explicit reasoning rather than just predicting the next word, right? And the example is a farmer has 10 cows, but all three ran away. How many cows are left, right? Yeah, if we parse through this as a normal mathematical equation, it could answer 7, right? But without COT, or it would probably answer 7 incorrectly, right? It would probably answer some text response and not a numerical value in what we're looking for, right? But with COT, it would pay attention to the phrase all but 3 remain, so the answer is 3, right? But then it looks like the other context, right? 10 cows. So then it would conclude to being 7, right? It breaks it down to logical steps. And the key benefits of COT prompting, as mentioned, it forces explicit reasoning, increases accuracy, and not only that, it reduces hallucinations, right? And an example is Google Minerva. It's a primary example of COT because it breaks down math problems and can solve it and excel in these things, right? So the upsides and downsides of reinforcement learning, right? Um, I'm gonna go off memory what I remember here, but it basically enhances AI creativity and ethics, right? It allows AI systems to generate more creative and context sensitive outputs by leveraging human feedback to optimize the model's performance. The AI can learn to generate content that aligns more closely with human preferences, right? And then for fine-tuned subjective outputs, it basically often you know traditional learning is often optimized for objective metrics like accuracy or efficiency, but reinforcement learning brings a layer of subjectivity, right? Human feedback allows the AI to learn to balance multiple competing factors such as humor, creativity, and appropriateness, which may not be captured numerically, right? And what are some limitations of it, right? It's the manipulative of reward function. So, um, the reward function can, even though it's a plus, it can be also like a double-edged sword, right? It can be easily manipulated or misaligned with the truth or ethic goals, right? Since the AI's behavior is largely guided by human provided feedback, humans inadvertently reward like behaviors that we don't want, right? And the AI will be more optimized towards this engagement, right? So I think a good basis for this is like AI generated images of people where it's more predominantly catered to on the data set it was trained, right? So it might not generate other like races correctly, right? And uh, it also introduces bias because of human feedback, right? And these preferences, like I was mentioning, can be reflected in cultural perspectives or values that not might be applicable, right? For instance, if the feedback is from a specific demographic, the model could unintentionally reinforce this bias, right? And that's one of the things that are faced with reinforcement learning, right? So that basically sums up my presentation. Thank you so much.